This is Mr. Precella, continuing our discussion of solving quadratic equations in my college algebra class. We'd already reviewed solving a quadratic equation by factoring and did a few problems, and we were now going to discuss solving a quadratic equation using the square root property. So to do that, I think I'll introduce this by way of an example, because I think most of you can sort of figure out. Let's see, if we were told to solve this equation, solve x squared equals 49. Solve x squared equals 49. Just by inspection and knowing the multiplication tables, I think most people would say 7. And if I then said, well, okay, that's one of the answers, positive 7, but there's another answer, and I say the positive 7, that's usually enough for people to decide, okay, also negative 7. Negative 7 times negative 7 would also give you a positive 49. So what am I doing going from here to here? Well, I'm taking square roots. I'm taking the positive and negative square root of that number 49. So with the square, you can use the square root method if you have an equation in the form just x squared equals some number, or variable squared equals some number. That's when you can use the square root method. So let's look at a couple of homework problems. This is problem number 14 that I'm about to do. Solve this equation using the square root property. Well, there's a t instead of an x, but either way, you've got to have it in the form variable squared. If you have it in the form variable squared equals a number, then it's tailor-made for this. And so what we could do is just move that t squared over and write it as 12 equals, so add t squared to both sides. 12 equals t squared. Now, if the fact that the variable's on the right bothers you, if you want to rewrite it t squared equals 12, that's fine. A equals B is the same thing as B equals A. But it doesn't bother me. I'm going to leave the t over here. And then I'm going to take the positive and negative square root of that number 12. And y'all remember how to simplify this? At this point, you know something? I'm now writing it with the t here. Let's see. Well, the square root of 12, that's not going to be an imaginary number, because 12 is not a negative 12. You're taking the square root of. So let's see, what perfect square goes into 12? How about a 4 times 3? So this would be a plus minus, the square root of 4 is 2. The square root of 3 you can't simplify. So if you were just going to write out the answer, it'd be plus minus 2 square root of 3. But when you're typing this in, my math lab doesn't have a plus minus key. You've got to type that in as positive 2 square root of 3, then a comma, negative 2 square root of 3. Or if you want to do the negative one first, that's fine. Negative 2 square root of 3, comma, positive 2 square root of 3. There's a little square root key on the left that you just click and it does it really quickly. Now, number 5, same type of problem. This one's already got the x by itself. In fact, this one's very similar to that little example I did. This one here, except what? You have to remember something we did in the first lesson. When you take the square root, you'd have x equal plus or minus square root of negative 81. Now, what's that square root of 80? Well, the square root of 81 is 9, but what am I trying to hint at or suggest that the square root of negative 81 is? Y'all remember that? It's an imaginary number. So you write plus minus 9i. Ooh, I circled that, but that's not really what you type in. You're going to type in 9i, comma, negative 9i, or if you want to go negative 9i, comma, 9i. When you're typing answers in with my math lab, don't use any capital letters and don't hit the space key. It'll space it accordingly. Okay? Ooh, now look at number 6. That's a multiple choice one. And at first glance, you're thinking, oh, wow, that doesn't look anything like problems 4 and 5 or the example you did. But really, when you look closely, going from here to here, taking those square roots, we just drop the square on the left, and then we're taking the positive and negative square root of the number on the right. So just drop the square on the left, positive and negative square root of the number on the right. We can do that here. Dropping the square on the left, and then positive, negative square root of the number on the right. Now square root of 21, can we simplify that? No. Okay? There's no perfect square. What are the only numbers you can think of that go into 21? 3 and 7, and you don't know the square root of those. So now let's go through and get that x by itself. What would I need to do to get the x by itself? Well, first thing is this 2 here. I'm going to move it over by adding 2 to both sides. So we have 2x equals 2 plus or minus square root of 21, and then divide by 2, but divide by this 2. That's sort of, sometimes if there's one or multiple choice, people would get all, okay, let's start canceling these 2's and stuff. But remember, if you're going to cancel, you'd have to separate, and you'd still have the 2 over here. So on this one, we're going to leave it like that. If you're thinking, oh, reduce it, well, 2 over 2 you could write as 1, but remember you'd still have the square root of 21 over 2 there. This is called the square root method. Oh, good. Here's another one. Number 7. Oh wow, this is just a 3-choice multiple choice problem. Okay, huh? Usually there's 4 choices on there. Well, we do the same thing that we did on the other one. Dropping the square on the left, taking the positive and negative square root of the number on the right. And this is where we look at the square root and see, can we simplify it? And normally I would say, well, square root of 14, 2 times 7, you can't simplify like that. But you can rewrite it as an imaginary number. The square root of a negative is an imaginary number. Don't leave that negative under the square root. Write it as an imaginary number. And then the only thing left to do to get the z by itself is subtract 6. So negative 6 plus or minus I square root of 14. That would be this one here. Okay. And then now we're going to start looking at the quadratic formula. Let me go ahead and state the quadratic formula. See, there's pros and cons. This square root method, if it's written in this form, you could write it, or you could solve it very easily, okay? It's already written like that, using the square root property. There's a method that allows you to take any square root and write it as, any quadratic equation and write it so you could use the square root property called completing the square. And we'll discuss that a little later. It can also be used to derive the quadratic formula. What I'm going to do is just state the quadratic formula, and we'll discuss completing the square later. So, quadratic formula. This formula will always work. By always, remember factoring, sometimes you might have a quadratic equation that won't factor. So here's one that will always work. This is the quadratic formula. The solutions of ax squared plus bx plus c equals 0. Again, this is where a isn't 0. Are given by x equals, what I'm about to write is what people think if they say state the quadratic formula. It's one of those universal formulas every algebra student has it memorized. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So the equation needs to be in the standard form with a 0 on one side, just like if you were solving it by factoring. So on problem number 8, what you need to do first, you need to 0. That little arrow means add 34 to both sides. If you want to write it like this instead of with the arrow, the equation we're solving is y squared minus 12y plus 34 equals 0. Sometimes students will say, well, wait, couldn't we do this by factoring? But I think that this one's not going to give you something that'll factor, okay? And generally when I say I think, I really mean I know, but it's not going to really give you something that'll factor. What could numbers multiply together to give 34? 1 times 34, 2 times 17. It's not going to factor. So now, I'm going to write out. It's in standard form with a 0. So A is 1, B is negative 12, and C is 34. So I'll just come right down here to do this one. It's number 8. Minus B. When I plug a negative 12 in here, I actually have two negatives. I have the pink negative from the formula, replacing the B with a negative 12. You have negative 12. That's going to be a positive 12. Plus or minus the square root of B squared. One of those things that showing too many steps doesn't make it easier. If there's something that you can do in your head real easily, go ahead and do it. The b squared, negative 12 times negative 12. I think that's something you can do in your head. Negative times negative is positive. 12 times 12 is 144. Then minus 4 times a times C. I guess for the times I'll use parentheses. Times A times C all over 2 times A. That's something else you can do in your head. 2 times A, 2 times 1 is 2. So I'm going to simplify under my square root right now. Clear this. I'm going to plug in the 144 minus 4 times 1 times 34. And that gives me an 8. Okay? I'm simplifying under the square root. The 144 minus 4 times 1 times 34 is 8. So underneath here, all of that, we have the square root of 8. And can we simplify square root of 8? Well, sure. You can think of that as square root of 4 times the square root of 2. So you're going to wind up with what? 2 square root of 2. So square root of 8 reduces to 2 square root of 2. So coming back up, what I've done right here is simplify under that square root. That's the pattern I'll use whenever I'm doing the quadratic formula. Now let's see, this negative negative is a positive 12. Then we have the plus minus 2 square root of 2 all over 2. And now there's two ways you can simplify this. You can either do the separating, or if you look just at the numbers that are not under the square root, the 12, the 2, and the 2, ask yourself, what could you divide both of them, all three of those by? Well, by 2. So you can either separate it, or just divide by 2, divide by 2, divide by 2. Either way, you'd get 6 plus or minus 1 square root of 2 all over 1. So just 6 plus 2 square root of 2, 6 plus or minus the square root of 2. And, to type in your answer, you can't type in the plus minus. So you're going to type it in like this. 6 plus square root of 2, comma, 6 minus square root of 2. But when you type that in, don't hit any spaces. Sometimes students hit too many spaces, and my math lab sort of has a hard time figuring out what they're typed in. Now let's try another one. This is problem 9. Let's see, number 9. Oh, wow. Do we have to do a little work on it? Can you see that one? What are we going to have to do first in order to use the quadratic formula? Well, we're going to need it in that standard form with the 0. X squared x constant equals 0. So I'm going to need to move this 2x over, or if you want to subtract 2x from both sides, then what we're going to be solving is x squared minus 2x plus 37 equals 0. A is 1, B is negative 2, and C is 37. Here's the quadratic formula. Minus B. Notice, once again, we're going to have two negatives. We're going to have the pink negative, and then when you plug in the negative 2, negative, negative, that's going to be a positive 2. That minus B just means change the sign on B. Plus or minus the square root of B squared Well, negative 2 times negative 2 is 4. Minus 4 times 1 times, times A times C would be times 1 times 37 all over 2 times A. 2 times 1 is just a 2. So like the other one, I'm going to plug into my calculator. Let's see. So I'm going to punch in 4 minus 4 times 1 times 37. Ooh, that's a negative 144. So I'm simplifying under the square root. Punching all of this in, I would have a negative 144 under the square root. And do we know how to simplify that? Yeah, the square root of negative 144, because they're taking the square root of a negative, there's going to be an I. The square root of 144 is 12. So that step under the square root symbol reduces to just a 12i. So we have a positive 2 plus or minus, all of that is 12i all over 2. And either divide all of those by 2 or separate. 2 over 2 is 1 plus or minus 12i over 2 is 6i. Ooh, but that's not how you're going to punch it in. Over here you'll punch in 1 plus 6i, comma 1 minus 6i. Lowercase I, no spaces. Let's see. Sort of the same stuff on these. Number 10, I'll put the formula right there. And it might not be a bad idea for you just to write the formula down every time you use it until you have it memorized. So I like to write out the values of A, B, and C. Here, A is 1. Notice it's already in the standard form. B is 5, and C is 1. So minus B, that would be a negative 5. Oops, there went the lights. Nothing wrong with your computer. Motion sensor in this room is hyperactive. So minus B plus or minus the square root of B squared, 5 times 5, 25, minus 4 times A times C, all over 2 times A. 2 times 1 is 2. Oh, wow. This one, I'm not even going to insult you with the calculator on here. 4 times 1 times 1 is just 4. 25 minus 4, this would simplify to square root of 21. And I think we've already had a square root of 21 pop up today. You can't simplify that square root of 21. What numbers divide into it? 3 and 7. 21's not a perfect square, so you can't simplify square root of 21. So we have negative 5, then plus minus square root of 21 all over 2, which doesn't reduce. Right here. And just sort of flying through these. Might not be a bad idea for you to take a moment, write this one down, and try it on your own. Okay, you might pause the video, try it on your own. And if you can get it done, then you might say, okay, I've seen enough of this video. Let me start working these problems. Also, it might not be a bad idea to print out your homework, to have it as we're going through this, just to compare your problems and mine. This one's very much like that one up there, isn't it? It's already in standard form. So A is 5. B, sometimes students will say B is X. Oh no, A, B, and C should be numbers. B is 1. C is -7. So when we start, when you plug a 1 in here, you have a -1 plus or minus the square root of B squared. 1 squared is 1 minus 4 times A times C all over 2 times A. 2 times A, we can do that in our head. 10 that's good right there. So I'm punching in under the square root symbol. The 1 minus 4 times 5 times 7. Oh, let me clear that out. 1 minus 4. I'm just hitting those parentheses, I'm just using for times. Times 5 times 7. Ooh, that's a -139. No, it can't be. Oh wait, C, look at that, I messed up. C is a -7. Did y'all see that? How did I know I'd messed up? Well, I was getting a 139 and I was sort of suspecting I should have a 141. Let me punch that in again correctly. It's 1 minus 4 times 5 times negative. Ooh, the negative is way down here. Ooh, am I doing this? You're gonna see, this is the negative right here that I'm about to punch. Not the subtraction. 7. Okay, so it is a 141 underneath all of that. So we have a square root of 141. So -1 plus or minus, and that's a positive 141 underneath that square root, all over 10. So it is going to be this one right here, isn't it? Okay. Let's see. We'll do number 12 now. This one requires that we rewrite it a little. You need a 0 on one side, and I think it's always easiest if we have it written with first term positive, if A is a positive number, not a negative. So I'm moving everything over here, which means I'm subtracting the 4x and adding 13. I'll just do it on scratch paper. So there's the equation. So A is 1, B is -4, and C is 13. Plugging in minus B B is -4, so if you have a pink negative followed by a purple -4, that's just going to be a negative. So a +4 plus or minus the square root of b squared. That's something you can do in your head. The b squared. -4 times -4 is 16. Minus 4. I usually put parentheses, but if you want to do like the calculator, put a little star, times A times C, all over 2 times A, 2 times what? What number's underneath that square? In the bottom of this fraction. 2 times A, 2 times 1 is 2. You can do that in your head. Now, okay, so I'm punching in 16 minus 4 times 1 times 13. That's a -36. So we have the square root of -36. All of this right here. And how would I simplify that square root of -36? It's the square root of a negative, so there's going to be an I, isn't it? And the square root of 36 is 6. So 6i. So we have 4 plus or minus 6i all over 2. But don't just cancel this 2 with one of those. You separate it. Or you could just divide each one of these 3 numbers by what? What's the biggest number that you can divide all of those by? 2. Either way, you're not going to wind up with a fraction any longer, are you? 4 over 2 is 2 plus or minus 6i over 2, 3i. So you're going to type in 2 plus 3i, comma, 2 minus 3i. 4. Okay. Let's see. Only 3 more of these. We're going to have to go quickly through them. Okay, number 13. Well, this one's already in standard form for to use a quadratic equation, quadratic formula, isn't it? Number 13. This is number 13 that I'm doing. Yeah. So I'll make a note. A is 1, B is 3, C is -8. So I have it printed out. So A is 1, B is 3, C is -8. So giving you a moment there to try it a little on your own, as I was here having someone came in the classroom and was asking me something. Okay, so plugging into the quadratic formula. Minus B would be -3 plus or minus the square root of B squared. 3 squared is 9. Minus 4 times A times C. Ooh, this is why parentheses are usually better, because I don't want this negative to get lost with that times. So we have b squared, which was 3 squared, which is 9, minus 4 times a times c, all over 2 times a. 2 times 1 is 2. So negative 3 plus or minus. Let me get up that calculator. Oh, well, I guess I should have it over here. It shows so well. No glare. Okay. I'm going 9 minus 4. Notice I hit the subtraction key. Can y'all see that? Times 1 times. Now I'm not going to hit this key. I'm going to hit the key that's down here under the 3, the minus in the, right there. Negative 8. So I punch to 9 minus 4 times 1 times negative 8. That's going to give me a 41. So underneath that square root symbol, I just have all of this. It's just a 41. And the square root of 41, that can't be reduced. 41. I made that square root symbol here way too big, didn't I? All over 2. You can't simplify that square root of 41. And this is it. And you'll have to type in negative 3 plus the square root of 41 all over 2. And negative 3 minus the square root of 41 all over 2. Or if you want to type the minus one and then the plus, the order doesn't matter there. Okay? If you're in one of my face-to-face classes, then I'll be showing you how to type this in class. You're in the online class, you're having trouble with it. You might want to go to the typing in. There's little fraction keys that you hit on the left and a square root key also. Okay? Make sure when you type the square roots, you type 41 and don't put any spaces after it under that square root symbol, because that can throw off my math lab. Usually some student tells me, well, I got the right answer, but it said it's wrong. It's something wrong with how you typed it in. You're either hitting a space key. That's the most common mistake. Okay. Oh, we only 2 more of these to get due. So look at number 15. Okay, so only 2 of these left to do. Well, when you're solving a quadratic equation, whether you're factoring or using the quadratic formula, and I mentioned this already, I always like this first number here to be positive, positive, not a negative. Ooh, there it goes again. So I always like this first number here to be positive. So instead of moving everything over to the left, I'm going to add 5x squared each side. That's going to put the 0 on the left. And then 5x squared minus 3x plus 15. Okay. Now, there's certainly nothing wrong with having the 0 on the left rather than on the right. Okay. Something equals 0. It's the same thing as saying 0 equals something. Equality is reflexive. A equals B is the same as saying B equals A. Okay. So A is 5. B is negative 3. And C is 15. Plugging in now. Right here. Oops. There's the A, B, and C. So minus b. There's a pink minus and then a green negative 3. That's just going to be a positive 3. Minus b means change the sign on b. Plus or minus the square root of b squared. Negative 3 times negative 3 is a positive 9. Minus 4 times a times c all over 2 times a. 2 times 5 is 10. This is where I'm going to pull up my calculator and simplify under here. If you can do this in your head, or I'm not saying you can't, I just need some way of showing my thought process here. And so punching it in here seems to be the best way in class. I'm simplifying. Visible. Under the square root. 9 subtract 4 times 5 times 15 a negative 291. Ooh, so underneath this purple square root symbol is a negative 291. And if we think about that, well, the square root of a negative number is an imaginary number. So we're going to have an I there. And now the numbers have gotten a little big. If you're wondering, well, can I simplify 291? Is there a perfect square that divides into 291? If you started actually going through dividing, let's see. 291 divided by 9. Does that go even? No. 291 divided by 16. Well, no. 291, what's the next perfect square? 25? Well, it's sure not going to be 25. No. 291 divided by 36. Nope. 291 divided by 49. No. I'll try one more. 291 divided by 64, and I'll try one more. Let's see, that was 8 times 8, 9 times 9. What about 291 divided by 81? Does that divide evenly? No. So 291 is one of those prime numbers. Well, no, no, it could divide by 3. It's not prime, but you can't simplify it any further. You're just going to have to leave the 291 under the square root symbol. So we have 3 plus or minus I square root of 291 all over 10. And we can't simplify that any. So when we type it in, probably the easiest way to type it in would be 3 plus I square root of 291 over 10, comma, 3 minus I square root of 291. There goes the light, all over 10. Again, there's nothing wrong with your computer. That's how you would type it in with My Math Lab. At least at this stage of the game in My Math Lab history, there's no plus minus key. I keep thinking they're going to put one over on the left that you can hit to punch in a plus minus. And we're about out of time. But we have just enough time to do one more. Sometimes number 15 looks terrible because of the fraction, but if you have an equation with fractions, somewhere along the way you've done this for linear equations, you can always clear the fractions from an equation by multiplying straight through by some number. Multiply every term. Terms are separated by pluses and minuses and equals. So there's 1, 2, 3, there's 4 terms here. what I'm going to do, and there's no reason why, if you want to say a equals a half, b equals 1/6, and c equal -1, if you just want to say, hey, it's in standard form, but a, b, and c are fractions, there's nothing wrong with that. But for our purposes, what we're going to do, I'm going to multiply straight through by some number that will cross-cancel. Do y'all remember how? Let me get a clean sheet of, oh, I'll just write it right here. I'm rewriting this problem. Sort of spreading it out. Because I'm going to multiply straight through by something here that will cancel out these denominators. What you're going to use is what's called the least common denominator. If we're adding a half and a sixth, what would that common denominator be? Well, 6. It's the smallest number that 2 and 6 both divide into. Sometimes students will say 12, but yeah, that's going to be a little bit too big. So what I'm doing is I'm going to multiply by 6 here. And the reason I'm doing this is I think it's easier to multiply fractions than it is to actually work with, usually multiplying fractions pretty easy. So notice each one of these terms gets multiplied by 6, even the 1, or the -1, and even the 0. The reason I'm doing that is because now look at how I've written it. Remember how you cross-cancel when multiplying fractions? This 6 over 1 times 1 over 2. Does this 2 cancel? Remember the cross-canceling when working with fractions? You can say, okay, 2 goes into 6 3 times 1 is 3. So now the equation's starting to look better. By better, I mean there's no fractions. So we have 3x squared plus what? Just 1x. I'll go ahead and write the 1, because that's going to be our b value, isn't it? Minus, and here's the mistake. A lot of times students forget to multiply the 1 by 6. They only multiply the fractions. No, every term gets multiplied. 1 times 6 is 6. 0 times 6 is 0. So, A is 3. See, doesn't that look a lot better? B is 1. C is -6. And if you didn't like multiplying 3 by 6, maybe you want to use A equals a half, B equals 1 over 6, C equals -1. Try it like that, and then maybe come back and see. Multiplying by 6, it's pretty easy to multiply fractions. A fraction by 6, or to multiply numbers by 6. So, using the quadratic formula now, minus b, there's going to be a -1, plus or minus square root of b squared. I can do that in my head. 1 times 1 is 1. Minus 4 times a times a -6. All over 2 times a, 2 times 3 is 6. Put in my calculator now. And I'm punching in this stuff right here. 1. 1 minus 4 times 3 times, now this is a -6, not a subtract 6, -6, enter, 73, so underneath the square root symbol here we have a 73, and 73 is one of those numbers, if can try dividing it by 9. No perfect square is going to divide into it. 16 doesn't. 25 doesn't. What I'm doing is trying to see, can I reduce that 73? Remember how we would write them as a perfect square times some other number? There's no perfect square that divides into 73, is there? So 73, the square is 73 is the number under the square root symbol. So we have -1 plus or minus square root of 73 all over 6. And we couldn't reduce that square root of 73, so we can't reduce this any. So, so the way you type it in, -1 plus square root of 73 all over 6, comma, -1 minus the square root of 73 all over 6. There. And that's what you would type in for that. So that ends up this lesson over quadratic equations. I know some of you have solved or seen the quadratic formula in previous algebra class. High school, they certainly do it here in the state of Texas. Intermediate algebra, you might have seen it in. But if not, you just, okay, you'll work on it, and it's one of those formulas that'll be popping up throughout the semester in your homework and so forth. And it's certainly one that you should take the time and memorize it. Maybe write it down every time you use it until you have it memorized. Okay? So that's it for now. I've talked too long already, so goodbye.